We're working on transformations, and transformations are about moving a graph up, down, left, right, something over an axis, reflecting. So we're going to be moving graphs. Here's a graph here of a function f of x. And so the question is, if now I take f of x and then I add 3, what does that do to the graph? And here is the first rule, that if I give you f of x and then I write f of x plus 5, it means up 5 units. You move the graph up 5 units. If it was f of x minus 7, it would be down 7 units. And so the thing to remember about this is that when the number is added on the outside of the function, it's up, down. So outside the function means up, down, and positive means up, negative means down. Here we have f of x plus 3. Which one of these moves this graph up 3 units? 1, 2, 3. It should be at level 2, and this is the only choice. It's A. F of x minus 1. So if I did f of x minus 3, it would mean 3 units right. So it's the opposite. If I did f of x plus 5, this would be 5 units. And this is left. So when we have f of x plus c, then c, first of all, it's on the inside, and it moves left, right. And a positive means left, a negative means right. On the inside, it's the opposite. For this one in particular, f of x minus 1 means I'm going to move 1 unit right. There's only one graph here that moves this thing 1 unit to the right. That would be this one. Now we're going to start combining them. 3 units right, 1 unit down. Which one of these moves it 3 units to the right and 1 unit down? And this is the only one that is remotely going to the right. And it's going to go down as well. Minus f of x plus 1, the minus sign in front flips over the x-axis. So if I have minus f of x, it flips over the x-axis. I then have a plus 1, so I'm going to flip this over the x-axis and then move it up 1. So I'm going to flip it over the x-axis. It then goes from negative 2 to positive 2, and then I'm going to move it up 1. The only one that does that that goes here. So then it should be at 4, is this one. 2 times f of x. 2 times f of 2. This is currently at 2. To multiply everything by 2 would mean that this is now going to move to 4. There's only one of them that does that, and it's this one. Here, f of 1/2 x multiplies x by 2 inside. It's the opposite. So then I need to stretch this from 2 to 4. And stretch this from -2 to -4 2. Only one that does that. This one. So multiplying by 1/2 on the inside doubles all the x values. Find the domain of the function. So the remark here is that if not dividing by 0 or taking a square root, then the answer is this one, -infinity to infinity. So here I'm not dividing by anything, I'm not taking a square root. That is the answer. Here I'm dividing, and so when you're dividing, you have to make sure to avoid where the denominator is equal to 0. Here, x minus 10 is equal to 0 means add 10 to both sides. X is equal to 10. Must avoid 10. That means on the number line, 10, I want all of this, not that, all of this. That would be, in interval notation, -infinity to 10, union with 10 to infinity. Here we're combining functions, adding, subtracting, multiplying, and dividing, and finding the domain. Here we're when you add, it's going to be 4x minus 9 plus x minus 2, and it boils down to combining like terms, 5x minus 11. Subtract is exactly what we would expect. It's 4x minus 9, but be careful here is minus x minus 2. 4x minus 9, distribute the minus sign, minus x plus 2. 4x minus x is 3x, negative 9 plus 2 is minus 7. Multiply just means we have to FOIL. F times g equals 4x minus 9 times x minus 2. Multiply 4x times x is 4x squared. 4x times minus 2 is minus 8x. Minus 9 times x is minus 9x. Negative 9 times negative 2 is plus 18. 4x squared minus 17x plus 18. And then we'll divide. Oh, by the way, the domains, well, this is a good time to stop. The domains for all of these, this one, this one, this one, we notice that we're not dividing, we're not taking the square root. It's going to be minus infinity to infinity. However, for this last one, when you divide, we'll put a big O however here. But for f over g, that equals 4x minus 9 over x minus 2. And now, a serious problem. X minus 2 is equal to 0 when x is equal to 2. We do not want to. So that means the answer is minus infinity to 2, union with 2 to infinity. That is the domain. But 4x minus 9 over x minus 2 is the answer. And then when you write the domain, just make sure you skip over 2. All right, thanks a lot.